The topic of today's lecture is strings and char, which are a bit different in Java than they are in Python. Okay, so in Python there is no a string. There's no such thing as a char in Python, right? So the whereas in Java, the individual characters of a string, there's actually a special type for them, right? So a string literal, so whenever I write something in double quotes, that's a Java string literal. You have to use the double quotes in Java. The individual characters, they actually have the type char, right? So you can get a character of a string and store it in a variable of type char using this method char at. Now we're going to come back to this method shortly, so don't worry about that quite yet. So I'm just talking about chars right now. If you want to write down a char in C, you use the single quotes. So one letter or digit or symbol, right? Anything you can type in basically inside of a pair of single quotes indicates a char. Right? And you use the type char to store those values. You can have a blank, right? So one space is fine, right? So that corresponds to the space character. But what you cannot do is you cannot put single quote, because there's no such thing as an empty char in Java, right? Just like there's no such thing as an empty int or an empty double, right? There's the value 0, but there's no notion of no int, right? Just like there's no notion of no char. So that doesn't work. Char is actually an integer type in Java. So the language says that the way you map an integer, a char value, to a specific character is defined by this thing here. So Unicode is a standard that tries to define a mapping between to every possible human written character, right? So whatever length, it tries to define the mapping for every language on Earth, right? And you also get things like emojis and other symbols that aren't part of any written language, but they're part of the Unicode standard, right? So if you imagine how many possible different written symbols there are, it's a very large number. So that's why Java chose to use this particular definition of char, right? So the minimum char value is 0, and the maximum char value is 65,535. And that number is actually not big enough to define all of the characters in the Unicode standard uniquely. So in fact, their choice of using a 16-bit value to store char values no longer works to store the mapping for all possible characters. Now, notice that when I print out character min value and character max value, the type of these two values is actually char. So when you try to print something with println, and if println sees a char value, then Java will try to print the thing here as some sort of symbol, right? So it'll try to print the symbol corresponding to 0, and it'll try to print the symbol corresponding to 65,535, which I don't want, right? I actually want to print the numbers 0 and 65,535, which is why I have to take the char value and convert them to int, right? So this notation, round bracket, with int inside, this is called a cast in Java. Right? So the way a cast works is it applies to the thing immediately on the right-hand side of the cast. Right? So it applies to this value here. And what it'll try to do, it will try to reinterpret this char value as an int value. Right? And this one will try to reinterpret this char value as an int value. If the cast is successful, then whatever's inside the round brackets, right, will now have an int value. Right? So that lets me print out the numbers 0 and 65,535. Without the cast, you'll get nothing because the symbol corresponding to 0 is a non-printing character. And on most of your computer screens, when you try to print out this value, you'll get something unusual. So in other words, you're not going to get a symbol that you recognize. So that's why I have to cast these values. Now, because it's an int, right? So sorry, because char is an integer type, you can actually write down the numeric value for a char instead of writing down its literal, right? So the char value 65, it turns out, is the capital A, right? Now, because they're integers, you can do arithmetic with them. So I can add 25 to C, and that gives you the uppercase letter Z. Right? So you can sort of guess that the way that the mapping works is that A, B, C, D, and so on through Z, they're all mapped in the same. Sorry, so they're all in sequence, right? So 65 is A, 66 is B, 67 is C, and so on and so on and so forth. You don't have to remember that A is 65, right? You can always look it up if you need to. Because you can do arithmetic with char, you would think that it's basically just like any other integer type in Java, but it's not. So char, short, and byte, they're all very weird when it comes to arithmetic. Okay, so you have to be a little bit careful when you try to do arithmetic with char short or byte. Okay, so if I start out with the letter A and I do C++, that actually works. So the compiler's happy with that. If you run your program with that line in it, it'll work fine. So it'll add 1 to C, and that'll be and C will the char C will now store the character uppercase B. Right, so that works fine. Plus equals 1 also works fine. So C will now store the uppercase C. Right. Minus equals 1 is fine. So C will now store uppercase B. What doesn't work is something like this, which is weird. And this also doesn't work. So if I define another char variable D, right, and I try to add C and D, right, this looks like it ought to work because that's a char, that's a char. So you would expect Java to compute the char value equal to the sum. But it turns out the language doesn't do that, which is very confusing. So numerical values correspond to a set. Say, yeah, that's exactly how it works, right? So there's this mapping called the Unicode Standard that defines exactly how the numeric values are mapped to symbols. So yeah, that's correct. Let's see. Gurpreet says C plus equals 1 or C equals C plus 1. Aren't they the same thing? They are not. So it turns out they're not the same thing. So let me explain what's going on here. So the way that the Java standard works is that it says if this is a char or a short or a byte, and you write C plus equals 1, Will, I'll answer your question in a second, right? So if this is a char and you write plus equals some int value here, then the standard says that it does what you expect it to. It adds 1 to the value of C. So what the standard actually says is as follows. It takes the current value of C, which is 65, right, A, converts it to an int, adds 1 to it using int arithmetic, you get 66, and then casts the value back to char, right? So it actually says something fairly complicated, right? Take the current value of C, cast it to int, add 1 using int arithmetic, cast the result back to char. Same thing with C++, right? So when it does the addition, it actually does the addition in integer using int arithmetic. Right? What else? Okay, now Java sees an expression like this, right? But the Java standard says, right, if you have 2 types that you're adding, they have different types. Right? So this is a char, this is int. Then what's said, the narrower type, right, the type that takes up less memory, right, is cast to the wider type, right? So C is a 16-bit value, right? Sorry, C is char, which is a 16-bit value. 1 is an int, which is a 32-bit value, right? So the standard says that char is narrower. Okay, it's hard to say for me. It's hard for me to say that word. Narrower than int. So the narrower value is widened to the other value, right? So in other words, the char is cast to an int, then the addition is done using int arithmetic. The result is not automatically cast back to char. So that's why this doesn't work, right? So you now have an int value on this side. You have a char value you have a char variable that you're trying to store the value in. Java doesn't let you store a wider value into a narrower value automatically, right? So to write this expression, right, c equals c+1, you actually have to put the c+1 in brackets, right, to do the to compute c+1, and then you have to put in front of it in brackets the word char. So you have to cast the result of the entire addition back to char manually, which is confusing, right? It's super confusing because these two work, but this one, these three work, but this one doesn't. But down here, now why doesn't this work? This is char, so shouldn't Java use char arithmetic to perform the addition? The answer is no. There actually is no char arithmetic in Java, right? So when you do arithmetic with char, short, or byte, those values are automatically converted to int, right? So that gets converted to an int, that gets converted to an int. The arithmetic is done using int arithmetic, and the result is an int, right? So again, you end up with an int on this side, which you cannot store in a char without a cast. So again, let me write this out for you. If you want to do that, right, then you have to write something like char f equals char. Okay, so why do I have to write this in brackets? Because I need to do the whole sum, right? I need to compute the whole sum before converting the sum back to char. If you just wrote char c plus d, no brackets, then it'll cast the c to a char, which it already is, so it does nothing. And then it'll try to add an int to it, so it'll become an int again. Okay, so that's why that doesn't work. So it's very confusing. You have to watch out for this when you try to do arithmetic. Fortunately, the compiler catches this error for you, right? So when you write it out in Eclipse, Eclipse will say, will underline it in red and say, hey, something's wrong here. Now we'll ask, is Unicode the same as ASCII? So the first, I forget how many numbers. I think it's the first 256 values are the same as ASCII, I believe. Certainly the letters and numbers are the same, right? So they have the same as mapping in ASCII as they do in Unicode. I'm not 100% sure, so you'd actually have to look that up. But I'm pretty sure it's the first 266 values are the same. And then Unicode adds a whole bunch of more values. So yeah, that's correct. Now, why would you want to do arithmetic with char? Right? So that's the question. And so the answer is because it's sometimes useful. So if you want to compute a string, or you want to compute a bunch of strings, right, then it turns out using arithmetic can be useful to do that. So for example, if I want to generate all pairs of two-letter uppercase strings, right, so AA, AB, AC, all the way through to ZZ, right, you can use a pair of nested loops to do this. Right? So I'm going to use start at the char value A, right, go up to and including the char value Z, right, and I'm going to go in steps of 1, right, so A, B, C, D through Z, right. The inner loop's exactly the same thing, right, so start at A, go up to and including Z, step 1 character at a time, right, and then I can make the string S inside the loop. So start with the empty string, right, and concatenate the C, right, the char C, and then concatenate the char D. Right? So the first time these loops run, you'll get AA, right? Then you'll get AB, AC, AD, and so on and so on and so on, right, up to ZZ. Right, so that'll actually print out all pairs of two-letter uppercase strings. Sometimes you want to loop over. A lot of the time, you want to loop over the. There's a lot of problems where it's useful to loop over the alphabet, for example, and so there you can use a counting style for loop in Java. Unfortunately, there's no way to use a for each loop in this case. Well, that's not true. You can use a for each loop if you put all the letters into an array, and then you can loop over the array. So you could do it that way as well. Okay, before I talk about strings, I need to remind you what a type is, right? So a type is a set of values and the operations that can be done with those values. Right? So int is a type. You know that the set of int is the set of integer values from integer min value up to integer max value. So that's your set of values. You know that the operations you can perform with int are things like arithmetic. You can do equality comparison, right? So equals equals, not equals. You can do greater than, less than, and things like that. So those are the operations that you can do with those values. So that's what a type is. Now, a class defines a user, a class is a user-defined reference type in Java. Right, so a class is creating a class automatically creates a new type. And so that's basically how you program in object-oriented programming, right? You create new types that you want to use, right? And those types are defined by classes. Now, depending on the information that you store, let me talk about objects first. An object is an instance of a class. Okay, so what does that mean? So when I write something like int I equals 5, right? 5 is an instance of an int. Right? So in other words, 5 is an int. Right? An object is similar for classes. So an object is just an instance of a class. Right? So an example here, string is a class. Right? An instance of string would be the string hello, or the string A, or the string B, or the string ABC. Right? So those are all instances of the class. We call those objects. Okay, so now that we've got that, we can talk about the string class. Right? So the string class is a class that represents text, right? So sequences of characters. If you make an object of type string, right, then that represents a specific sequence of characters. Strings turn out to be widely used in Java programs. So they're so widely used that they're considered fundamental to the language. And the language goes quite far out of its way to let the programmer use string objects as though they were primitive types, which is kind of unfortunate because it's very confusing, especially for people new to Java. So you can do things with string objects that you cannot do with any other type of object. So string is strange from a class/object point of view. Right. So for example, there are these things called string literals, right? So double quotes and some text, right? Just like there are primitive literals, but there are no literals for any other reference type in Java, and there's no way for the programmer to create them. Right. So that's a bit strange. The other strange thing is that string has an operator, right? So string, if you use the plus sign with strings, then that performs string concatenation. Right? So string is the only class where you can use the plus operator or any other operator with objects of the class. So there's no way for the programmer to create a new class where you can use, for example, the plus sign or the minus sign or division or multiplication or anything like that. Right? You can't do greater than or less than or anything like that. Right? Whereas in a language like Python, you are allowed to redefine how the operators work. Right. So, for example, in Python, it's possible to create a class where you can make objects and then write A less than B. In Java, you can't do that. Now, I should show you this. So there is the documentation for the string class and any other class in the standard library is accessible online. So hopefully this works. It'll work. Good. So to find the documentation, you don't have to remember that URL, right? If you're looking for information on a class, so it's, for example, Java string, right? If you type in something like Java string and then a Java version number, so like 8 or 17, that's for example, right? One of the first results will be this thing here, right? It'll be docs.oracle.com. It'll be string Oracle Help Center or something like that. open that up, you'll get the documentation for the string class. Now the string class hasn't changed in a long time, so I'm just going to use this link here. Right? And you'll end up on the standard documentation page for the class that you're looking up. Now Java is nice because the language actually, well, not the language. There's a tool called JavaDoc that defines how Java documentation is created. Right. So in other words, Java standardized the way that documentation for its classes, or well, it's standardized. Yeah. So it's standardized how you should document the class. Right. So whenever you look at documentation for a Java class, it always looks like this. Right? Up at the top, you get a very quick summary of the class and its relationship to other classes. We'll talk more about this later in the course. Right? Then you get a section here that describes what the class is supposed to be used for. Right? If you keep on scrolling, in the next part, you'll see something called the field summary. We'll get to that later on. You'll see the constructor summary. Again, we're going to get that later on. You normally don't use constructors with strings. And then you'll get to the method summary. So remember that a type is the set of values and the operations you can perform with the type. The methods are the operations that you can perform with an object. Right? Can't we do operation overloading? Sorry, Gurpreet, I didn't hear your question. The answer is no. Java does not support operator overloading. If you want to do operator overloading, you have to use something like Python or C++. One of the reasons Java took away operator overloading is because C++ gives you operator overloading. And it turns out that when you give programmers operator overloading, they like to do stupid things when they overload the operators. So they'll overload plus or minus to do something very bizarre. And it becomes very confusing to use those classes. So Java decided to take that away. Whether or not that was a good reason, whether or not that was a good decision is up for debate. Okay, so your methods are the operations that you can perform with strings. And if you scroll through the documentation, you're going to see there's a lot of methods. Right? And obviously, I can't talk about all of the methods because we'll be here for days. Right? If you click on a method, so let's click on to uppercase or to lowercase. If you click on one of these, it'll take you to the full documentation for the method. Right? So now you can read about what the method, a description of what the method does. Right? And normally, the documentation does not tell you how the method does what it does. Right? So it doesn't describe the implementation. It simply says what the method does. Right, and what it promises to return. Right, so it promises to return a string that's converted to lowercase, right, and things like that. If there's any exceptions that could be thrown by the method, the documentation will tell you that as well. Okay, now what you have to remember about strings is that they are immutable. Right? So a string object is immutable, which means once you make a string object, so if you make the string object hello, you can never change the letters of that particular string object, right? That's also true in Python. So the sequence of characters in a string object can never be changed, right? So if I make a string hello and I decide I want to make it capital H hello, right? There's no way for me to do that. I have to make a new string object that corresponds to the string capital H hello. When you look at the documentation for the methods, or if you just look at the name of a method, a lot of the methods look like they ought to change the string object, right? They don't. What they do is they return a new string object. So for example, to uppercase and to lowercase, right? They return new strings, right? That are the uppercase and lowercase versions of the string. And they do not modify the original string because you can't, right? There's no way to modify a string in Java. So if I make the string object hello, right, and then I write S to uppercase, right, that string there is still all lowercase hello. Right? So what the method does is it makes a new string object that's all uppercase hello. So big H, big E, big L, big L, big O, right? And up is a reference to that new string object. So if you print S and up here, you get lowercase hello and then uppercase hello. One of the most common errors you'll see new Java programmers make is they'll write something like this. They'll say, well, I've got this string S and I'd like it to be in uppercase. So I will just write S to uppercase, and they'll think that S is now in all in uppercase, right? Or they'll think that S refers to a string that's in all uppercase, right? It does not, right? S still refers to the string that's in all lowercase in this example, right? So if you want the uppercase version of a string, you have to store it in a new variable, right? Or use it right away. But we'll get to that a little later. Okay, now why, when I call this method, am I using a variable? Right? Because so far I've told you that all of our methods are static, right? And that you should always use the class name to call the method. So that's not the case here. So the method to uppercase and to lowercase, they are not static methods. Okay? So normally when you just say method in Java, people mean non-static method. Right? If they say static method, then they mean static method. Right? The difference between a static method and a non-static method is, for a static method, you use the class name to call the method. For a non-static method, you need some sort of object reference to call the method. Right? So to call to uppercase, I need a reference to a string object. In other words, I need S in this case. The way you call the method is to use the reference name dot and then the method name. If you look at the documentation, right, when you go to look at the documentation for the method, so let me scroll back up to the summary. Right? If you don't see static here, right? Sorry, here's two lowercase. If you don't see static in front of the return value, then it's a non-static method. You need an object to call the method. String does have static methods. So it's got the method called value of, and you can see here, you can see here, it won't let me highlight it, sorry, that the method is a static method. So if you want to use the value of method, you have to use capital S string dot value of something. So that's the difference between a static and non-static method. Static methods, you need the class to call the method. Non-static methods, you need an object reference to call the method. Right, so I just mentioned this, string does in fact have static methods. So the value of method will take the argument here and give you back the string representation of that argument. So in other words, it makes a new string that represents the double value 1.0. So that's what the value of method does, right? It's static, so we need the class name to call the method. Instead of using value of, though, you can always use string concatenation. So I can write empty string concatenated with the double value 1, right? And so Java will automatically convert that 1.0 to its string representation, whatever that may be. Okay, like in Python, a string is a numbered sequence, right? So you know that a Python string, you can use the square brackets to get to parts of the string, right? So you can get to an individual, you can get to any substring in a Python string, right? Using the square brackets and a numeric index. Right? Oops. How is that used? Isn't that the same thing as string equals? Aaron knows. That's a good question. Is it the same thing? The answer is maybe not. In this case, the answer is yes. But in reality, the answer is maybe not, because well, you'll get to this. We'll get to this in another lecture. But the so the floating point values are a bit strange the way they behave. Now, why would you use this? So there's a lot of cases where you would use this. Let me give you an example. Okay, so for example, so suppose I have the square root of 2. Right? Now, I don't know what that value is. It's 1.7 something, right? Now, suppose I want to print out that value, or I want to concatenate X onto another string, or I just want the string representation of X for some reason, right? Then there's no good way for me to write. And so now what do I write, right? I don't know what's here. Instead, just write X as string equals string value. Or you can write X as string X, right? That's how you would use it. Right? You have to remember that you have to get out of the mindset that you can always write, that you can always use a literal in programming, right? A lot of the time you don't have a literal, you just got a variable. So if I want the string representation of that variable, I need some way to get that. How long does the string end up being? So that's unknown, right? So there's no way for you to easily know that in this case. Right. So Java, the way Java works is it will take whatever the value of X is, and it will produce what it thinks is the string that most closely represents the value X. Right. Exactly how that does that is complicated. So you don't know how long the string is going to be. So that's the answer. For a number like 1.0, you can guess it's going to be 1.0, right? For the square root of 2, who knows, right? It'll be at most it'll have something like 17 or 18 digits after the decimal place, but you don't actually know exactly how long it's going to be, which is actually okay because you can just compute the string and then do X as string dot length to get the length. If you're concerned about how do you print the value using a fixed number of decimal places, then you use a method that can deal with that. So there are methods where you can specify how many digits after the decimal place should be printed, right? But the conversion to string, that's not within your control. I hope that answers your question. Right, so string's a numbered sequence. So you can get to each individual character of the string using a numeric value, an index, right? So the index, you have to use a valid index, right? Now remember in Java, indexes are always, they always start at 0. They are always positive or 0. And in this case, the last index that you can use is the length of the string minus 1. Right, so 0 through 6 are the valid indexes to get to the individual characters of this string. The number of characters in a string is called its length. Right, so if I have the string CISC 124, right, that's got 7 characters in it. So when you ask the string referenced by course name, what is its length? You get back the number 7. Make the empty string, right? So double quote, no space in between, right? No space, that's the space. Right? If you put a space in here, that's the space character. That's the string corresponding to the space character. Double quote is the empty string. If you ask the string referenced by the variable empty, what is its length? You get back 0. Oh, you have to be careful about this, right? So the fact that there are 0 length strings means that if you write a method that operates on a string, you have to remember that the string might have length 0. Right? So for example, if the first thing you do is get the first character of the string for some reason, then your method will fail if the string has length 0, right? Because there are no valid indexes for a string of length 0. The method char at returns the character at a specified index, right? So the index has to be valid, otherwise you get an exception. So for example, if I want to print out the individual characters of this particular course name, right, then I can write a loop, right, starting at index 0. Right? The index goes up to, but not including, the length of the string. Each time through the loop, I'll increase the index by 1. Right? Inside the loop, I can call char at, right, and get the character at index I, and then I can print that character. So that'll print out big C, then big I, then big S, then big C, then 1, then 2, then 4, right? Each character on a separate line. Here's an example of a class and a static method that counts the number of times a character appears in a string. So inside my class called strings with an S, okay, but a public static method called freq, or frequency, that returns an int, right? The method looks for that character in the string S and how many times it appears. Right, so how do you do this? Well, you just start with a counter, right? You start with the value 0. You write a loop that can loop over the characters of the string. Right? Inside the loop, you have an if statement that uses char at. Right? Now, remember, char is a primitive type. So I can check if this char is equal to target using equals equals. It's because char is primitive. Right? So if the character at index I is equal to the target character, increase the count by 1. After the loop is done, right? So after the for loop, you can return the count. You can't return the count from inside the loop. So there's an example of looping over a string. Now, there's no for each loop that works with strings, right? Which is kind of unfortunate because that would actually be very convenient. But it turns out for each does not work with strings. Because that's not the way the original string class was created, right? The original string class, so the for each loop didn't show up until version 5 of the language, right? And the string class hasn't changed, I don't think, since version 1 of the language, because it's so important to the language, right? If you change a class, if you make a significant change to a class, and the programming language is already widely used, then you force a lot of code to have to be modified or recompiled. So the really fundamental classes in Java, like string, have never been changed since their original inception, which means they couldn't add the mechanism that they needed to let you write a for each loop on a string. So can you compare strings to see if they're equal? You absolutely can, and I'll get to that in a moment. To use the frequency method in another class, right, you import the strings class, right? I should have put that here, right? So import strings, right? And then inside the main method in this example, right, to call the method freq, I use the class name dot freq, right, to call it. Just give me a second here to check my email because I have an exam happening right now. So I have to make sure that, okay. There's a deferred exam happening, so I have to make sure that people aren't emailing me about the deferred exam. Right, so static method, so class name dot method name, pass in the arguments. Right, so how many times does capital C appear here? Well, it appears twice, right? 2. How many times does lowercase c appear? There's no lowercase c here, so that's 0, right? So strings are case sensitive. How many times does the for appear? It appears once, right, at the end of the string. Contains is a method that returns true if a string contains a specified substring. Now, one of the funny things about the string class is that it's a bit inconsistent with its methods. So this is the other thing you need to be aware of. What did I char at, right? So char at returns a char. And there are methods, oh, sorry, and it takes, right, so it returns a char. The method I just showed you, right, the frequency method that I wrote, right, its parameter, and one of its input parameters is also typed char. Now, a method like contains is a bit, okay, so a method like contains, right, takes in something called a char sequence, right, which we haven't talked about yet. For the time being, you can think of a char sequence as just being a string, right? So contains actually requires you to pass in a string, right, as its input. So when you use the contains method, right, I want to know if the course name contains the string big CISC, right? So when I call the method, I have to pass in a string. Well, I want to check if it contains lowercase CISC, right? That's false. Does it contain the 4? The answer is true, right? Now notice when I ask, does it contain the 4? I have to pass in the string 4, right? I cannot pass in the char 4, right? So if I want to know, does it contain the character C, right? That doesn't work, right? Pass in, right? The character C, the compiler will say there's no method contains that takes in a char. Right? If you want to check if it contains the char C, you have to do something like that. Right? So double quote the C, or you have to convert your char to a C somehow, to a string somehow, right? Like concatenating it with another string. Now, this is a little confusing because there are other methods like index of. Index of will let you pass in a char, and there's another version that lets you pass in a string. So some of the methods work with chars and strings, some of them don't. Right? The only way you can find out is to refer to the documentation, right? Which is, so you have to keep that in mind when working with the string class. So index of tells you the index or the location of a specified character or string in a string. Right? You get back -1 if the character or string is not in the string. Right? So what's the index of the capital C? Well, it's 0 because it's the first character. What's the index of the capital S? It's 0, 1, 2. Right? What about the 4? Well, that's 6. What about the Z? Well, Z's not in the string, so you get back -1. Last index of is similar, except it tells you the index of the last occurrence. Right? So what's the last index of the C? Well, that's here. Right? So that's index. There's only one S, so you get back the same answer for last index of and index of. 4 is at the end. There's only one 4, so you get back 6. There's no Z, so you get back -1. I didn't tell you that here. You can use last index of and index of with a string. So if I asked what is the last index of CI, right, the string CI, then you get back 0, the start of that substring. Right. If I ask for the last index of 1, 2, then you get back 0, 1, 2, 3, 4. Right, the starting index of the 1. So index of and last index of works with both chars and strings. Rowan asked, how do you compare strings for equality? The answer is always use the equals method. Right? Do not use equals equals or not equals to compare two strings for equality. Right? It is by far the most common mistake that's made by new programmers, by programmers new to the Java language. Right? At least in my experience. Right. So, for example, last term's exam, I would say 75% of the students made this mistake on the exam. Despite the fact that there's a slide that says do not use equals equals to compare two strings. Right? If you want to compare two strings for equality, use the equals method. That's what it's meant for. So I've got two strings, CISC124 and math124. Are they the same string? Right? Do they have the same sequence of characters? The answer is no. Right? How do you check? CISC.equals math. Right? So the name of the variable of the first string, name of the variable that points to the second string. Right? CISC.equals math, you get back false. Right? Case matters. So if I write CISC equals the string lowercase CISC124, you also get back false. The problem with strings. Right? The problem with strings in Java is that equals equals works most of the time. So you can test your code and it looks like it works until it doesn't, which is super annoying. Now, this isn't so if you're a Python programmer, Python uses equals equals for just about everything, right? For almost everything, except when you want to ask the question, do two variables refer to the same object, right? So in Python, if you want to know do two variables refer to the same object, you use is, right? You use the is operator. I don't know if they told you that, but that's what you do. In Java, equals equals when you have objects is analogous to Python's is, right? So equals equals in Java tests for equality of identity, right? So if I wrote CISC equals equals math, that's asking, does the variable CISC refer to the same string object as the variable math? Right? So that's how the language was originally designed, which means that's the way it works today. So that's how it works in Java. Keep that in mind, right? Whenever you're working with objects and you want to know are two objects equal, use equals. If you're working with primitives, use equals equals and not equals, right? So you have to keep that in mind, right? Reference types, equality is equals. Right? Primitive types, equalities is equals equals. Since strings are immutable, no, that doesn't work. So for example, the problem is it almost works. That's the problem. It almost always works, right? So here, I can give you an example. Do I do it here? No, I don't do it here. Okay. So I'm going to give you a bunch of very bizarre examples. All right, so here we go. Now, equals equals, right? Tests for equality of identity. So, does CISC refer to the same string object, right? Remember, the same string object, not the same sequence of characters. Does it refer to the same string object as that? Turns out in Java, the answer is yes, because of the way the string class is designed. The string class goes out of its way to only make one string object if it sees the same sequence of characters, if it sees the same string literals in a program, right? So whenever you write the literal CISC124 in your program, language tries very hard to make only one literal, only one object for that literal, right? So here it is here, and here it is here. So it turns out there's only one string object corresponding to the string CISC124. That's why when you write equals equals, you get back true. Now, there is CISC124 again, right? So that string object is the same as that string object is the same as that string object. However, in this case, I used the new operator and a string constructor to create a new string object, right? So that's what new does in Java. New always makes a new object regardless of what the class does otherwise. Right? Now, the string class is forced to make a new string object, right? So there's now a second string object whose sequence of characters is 6124. Oh, wait, sorry, I screwed that up. Man, I really messed that up. I'm sorry. That's what I meant to write. Okay, sorry, that's what I meant to write. I apologize. Okay, so once more. This makes a new string object. It happens to have the same sequence of characters as that object, right? It's a different string object. So when you write equals equals, you now get false. And that's why, so you get false. However, oops. If you write CISC equal, right, so now there's a third string corresponding to the sequence of characters CISC124. Right, now there's three string objects, right? 1, 2, and then the ones that were made here by the literals. Right, so there's now three string objects equal to CISC124. Now if you use equals, you get true. Right, so equals does what's called logical equality, right? Is this variable and this string, sorry, is the string referred to by this variable, and is this string, do they have the same sequence of characters, right? Equals equals is identity of, is equality of identity, right? Do they refer to the same object? So when we check string equals string B, what exactly does it check? Value or address? In Java, it checks the value, but the value in Java, remember, so references, so remember, if you have a reference variable, like, so CISC and math, these are reference variables, right? What does the variable store? It turns out it stores something like the address of the string, right? Equals does equality of value, right? Now, what does a reference object store? Well, it stores an address. So it checks, are the addresses the same, right? Does it point to the, or right, do the two strings, do the two variables have the same, point to the same string object? Right, that's the other big confusion in Java. People think that value means CISC 124. That's not what it means in Java, right? Value for a reference variable means the address of the object. So that's what it's checking. All right. Now, all you have to remember for this is that, do I have a reference variable? Yes. Use equals. Do I have a primitive variable? Yes. Use equals. What kind of keyboard do I have? I have a Metadot, a DAS keyboard. What time is it? Oh, sorry, it's 22 after. We got to go. Slide 22. Okay, so I didn't get nearly as far as I should have in this lecture, but there was a lot of explanation. So that's the end of today's lecture. Anybody have any questions before we end this lecture? Anybody? All right. I should let you go because you probably have to, you may have to get to another class after this one. Oh, completely unrelated. Great. So let me stop the recording and I'll ask your completely unrelated. Oh, wait, sorry, I do have a related question. About the first lab, is there anything specific you wanted us to mention? No. Just pick some fact about yourself. Be random, right? Do you like cooking? Do you have a cat? Do you have a dog? Right? Do you want to where you were born or something like that? Right? Anything. So there's nothing specific. Do we need to use Eclipse for the lab? No, but you need to use it. All the lab. So anything I do in a lab is going to be related to Eclipse. So do you need to use Eclipse? Well, no. But if I show you, for example, how to debug in Eclipse, right, and you're using some other IDE, you're going to have to learn how to debug in your IDE instead. So if I show you how to, if I show you how to write a unit test in Eclipse, right, you're going to have to figure out how to write a unit test in your IDE instead. So if you're using a different IDE, that's fine for lab 1, but you might have a problem in subsequent labs. Okay. The lab should only take, I mean, if you've already installed an IDE in Java, the lab should take you like 5 minutes. Okay, let me stop the recording and I will answer the completely